Hello folks, in this video we are gonna find the derivative of a function by using implicit differentiation. Before we move on solving the question, I wanna show two different type of equations and their differences to see when we have to use implicit differentiation. Let's look the functions on the left. Y is a function of x and is isolated on one side. It is so easy to find derivative of y. We can use chain rule or product rule, whatever it applies. But the functions on the right, x and y, is related by more complicated expression, and it is tricky to write y in terms of x. We know y is a function of x, but isolating y on one side is not that easy. For this situation, implicit differentiation allows us to go straight to differentiate both sides rather than worry about the isolating y. Let's make it clear here. Differentiating both sides means taking derivative of both sides with respect to x. Another thing I want to mention is x is variable here and y is a function of x, even though we cannot isolate y. So when we are taking derivative of y, we differentiate the function y respect to x. So dy over dx is another notation of derivative of y. Let's look our question now. Y is equal to cosine x plus sine y. Let's differentiate both sides respect to x. Distributing derivative operator onto addition. Dy dx is same as derivative of y is equal to derivative of cos x respect to x is negative sine x plus. Here we have to use chain rule because of our assumption that y is a function of x. If you want to see more chain rule example, you can click on the link on the top or description section. Here y is the inside function, sine is the outer function. Take a quick look to chain rule here. Derivative of outer function with untouched inside function, which is cosine y, times derivative of inside function, which is derivative of y respect to x, which is same to derivative of y. Now, time to solve for derivative of y. To isolate y prime, subtract this term from both sides. Y prime minus cosine y times y prime is equal to negative sine x. Derivative of y is common factors here. Let's factor them out. Derivative of y times 1 minus cosine y is equal to negative sine x. Now we can divide both sides by this and end it with derivative of y is equal to negative sine x divided by 1 minus cosine y. Here we have another equation with x and y are related in a complicated manner. We can say y is a function of x but cannot be easily manipulated to solve for y in terms of x. So implicit differentiation is a perfect fit for this question. What was the first step for implicit differentiation? Differentiate both sides with respect to the x. Let's apply the derivative operator to both sides. Let's distribute the derivative operator into the addition. Derivative of a constant is 0, so we can say 0 to right hand side. Derivative of x squared respect to the x is 2x plus, we will use product rule here. For x is the first function, y is the second function. So derivative of 4x respect to the x is 4, and derivative of y respect to the x is just dy over dx. Let's apply the product rule now. Derivative of first function is 4 times second function is y plus first function is 4x times derivative of second function is dy over dx plus, we will use chain rule here. Y is the inside function and something square is the outer function here. Let's find the derivative of outer function. We are putting the power here 2 times inside function. Chain rule states that derivative of outer function of untouched inside function 2y times derivative of inside function respect to the x dy over dx. Dy dx is same as derivative of y. Let's substitute this in this step. Derivative of y terms is common here. Let's keep these terms on the left hand side and put the rest of terms on the right hand side by changing their signs. Y prime is common factor here. Let's factor them out. Leave behind 4x plus 2y. To isolate y prime, we need to divide both sides by 4x plus 2y. So ended with derivative of y is equal to negative 2x minus 4y all over 4x plus 2y is our solution.